In this video, we're going to talk about Venn diagrams. This will focus on sections 1 through 3 through 1 through 5 of the textbook. So what is a Venn diagram? Venn diagrams are a graphical tool or pictures that we use to visualize and understand relationships between sets. Those concepts are going to be intersection, union, universal set, and subsets. As you can see in the diagram here, we have three circles. We have the CS team, the engineering team, and the marketing team. We can see that some people are only in the CS team, some people are only in the engineering team, and some people only in the marketing team. However, there are a few people that overlap into more than one team, with Maxine and Audrey being in all three teams. This is where we can see the intersection of sets. We can then let the whole box be the universal set, and each CS, engineering, and marketing team are all subsets of that universal set, say, of a company name. So what is a Venn diagram? A Venn diagram is simply sets inside a universal set that are broken up based on a particular category. For example, let's suppose that we have a set of students. Students can either be in Spanish class, chemistry class, or math class. This Venn diagram specifically talks about the cardinality of each set. Cardinality is just a fancy word of saying number of in the set. So if there are, for example, 7 students that are in chemistry alone, we would have 7 here. In this case, chemistry, there are 17 students that are in chemistry, but are not in Spanish and not in math. Let's talk about the complement of a set. The complement of a set is a set of all elements in the universal set that's not in the given set. Now we can either describe that as either S little c, S little dash, or S bar. All these mean complement. So let's practice with that. Let's let this whole diagram be the universal set. And we have two subsets, apples and oranges. Let's suppose that we look at apples. Apples are green, red or green, they have smooth skin, and they grow in cool climates. They also share the fact that apples are fruits, and they're food, and they grow on trees, and they can be juice. Those are all things that oranges also do. If I want to talk about the complement of the set of apples, I'm going to look at everything that's an orange that's not apples. So this right here, I'm going to use this red color. All this would be considered the complement of apples. So if A is apples, then this set right here would be a complement. Coincidentally as well, here, everything that is apples that is not oranges, let's say this is O, this would be O complement. If there was fruit out here, then this is also part of the complement sets because it's not part of apples or oranges. So let's suppose we have limes. Let's if we were to. Now limes can also be juice, they're fruits and frozen grease. So I would also circle here and let this be limes. We could say then that we have citrus between those. But there really isn't anything in common with apples other than the fact that they could be green. But limes are also tart, unlike oranges and apples. Well, apples can be tart, so I guess we could put tart here too. The point is that complements can also be outside in the universal set that might not be in one of the subsets given. The intersection, however, is where the two circles intersect. Let's talk about complement and cardinality. So, if we're trying to find the cardinality of a complement set, it's important to know what sets are what, so that way we know which ones to count. In this Venn diagram, each number represents how many elements are in that set. In this case, how many students. So for example, there are 70 students that are taking Spanish that are not in chemistry or math. There are 5 students that are not in Spanish, chemistry, or math. Let's suppose we want to find the cardinality of the complement of the set of students in math. Let's do some coloring. Now we know that here, all this is math. So that means the 5, the 15, the 60, and the 85 is all math. Well, we want the complement. We want everything other than math. That means we're looking at the following sets. We're looking at this piece, this piece, this piece, and the 5 students that are doing none of those 3 classes. This is how we get the cardinality of the complement of math. 5 plus 70 plus 3 plus 17 gives us a total of 95. In this example, 95 students is the number of students in the complement of those taking math. If I were to write it in symbols, we would have n, complement math, and then there's a little check mark, which is another symbol for this little symbol right here. That little symbol right there means complement is 95. Now let's go ahead and look at the complement of chemistry intersection Spanish. Let's erase all this. Okay. In order to find the answer to this, we want to look at the sections we're interested in. Let's color what we don't want. Okay, well, let's first of all, we'll look at the chemistry and Spanish intersection. That's going to be these 2 sets right here. Okay? Now I want the complement of this set, which means I want everything outside of this intersection. Which means we're definitely going to want the 5 out here. This is not part of that set. This is not part of the intersection. This is not the part of the intersection. This is not, and this is not. Essentially, we're taking every other section other than the intersection of chemistry and Spanish. So if I want to find the cardinality, of the complement of chemistry intersecting Spanish, I'm going to take the 5, and I'm going to add the other 5, and I'm going to add the 70, and I'm going to add the 17, I'm going to add the 60, and the 85. 1, so I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We take our calculator, add those all together. 5 plus 5 plus 70 plus 17 plus 60 plus 85. We get a total of 242. So then the cardinality of the complement of the intersection of chemistry and Spanish would be 242 students. We'll do more problems like this in class to help visualize what we're trying to find.